Paint precision is one of the things that we're always focusing on because there's a lot that goes into it. It's the thickness of the paint, it's how the layers are going down, and it's the distribution around the ball and just the general coverage of that paint over the surface is all critical to the performance because anytime you put a layer on the golf ball, your aerodynamics are impacted, right? When we're going through the process of optimizing a aerodynamic pattern and we're looking at small adjustments to the trajectory of that flight, we're making tooling changes of 2 to 3 10 thousandths of an inch each time we do that. And like to put that in context for you, that's about the size of a red blood cell. So that's the depth that we can control in our manufacturing process, and it's the depth that we can detect through our testing process. So when you're dialing into that sort of precision, once you put paint on it, you have to put the paint on right. Otherwise, you can impact the aerodynamics negatively. If you put it on too thick, too thin, it's going to change how you think it's going to fly. And even worse, if you put it on differently on one half than you do on the other, then you can start to get left and right phenomenon when you're hitting the golf ball, and that's the worst case scenario.
How big a left-right dispersion are you talking about? If you have small differences between a left hemisphere and right hemisphere of a golf ball, what kind of flight differences would I expect to see?
So just to give you an idea, let's say I'm in the manufacturing process, and when we're in the paint process where balls are going through and you're painting it with 2 spray guns, putting on the layers. If for some reason only half of that golf ball got painted because the paint gun on one side wasn't working appropriately, and you teed it up in the right orientation, you could start to get 30 or 40 yards offline purely from aerodynamic changes in the side-to-side forces.